Okay, so the first part of today is kind of a review because we touched upon this part already, and we're gonna focus a little bit more and dive a little bit deeper into the practice. We are writing equations of parallel and perpendicular lines, right? What does parallel line mean? It means that they never meet each other. They have the same slope. That's why they never meet, because they're always going in the same direction. Perpendicular means they're going at a 90-degree with each other, and we've talked about how they behave. The slope of parallel lines are going to be what, Wilson? The same, yeah. Slope of parallel lines will be the same. So that's that. And one thing we want to do perhaps is maybe let's take a look at this picture and quickly check if they're actually parallel to each other or not. If you just eyeball it, they all look parallel to me, right? But if we actually do the calculation, we can see that the blue line, let me use blue, it has a slope, what? 2 minus 3 over 1 minus negative 4, which will give me negative 1 over 5, so negative 1/5. Okay, Timothy, help me out with the second one. Like, how do I set up the equation? Okay, we can do 0 minus negative 1, that is. Yeah, and then the bottom. Well, if you do 0 first, then on the bottom you want to do negative 3 first as well. So making sure you use the same point first, same point second. So negative 3 minus 1, that could work. So this is going to be 1 divided by negative 4. So this is negative 1/4. Okay, good. Yeah, Camille, can you help me with the last one? How do I calculate the slope for that one?
Yeah, so the slope for that one
Hmm.
would be so it's -5 minus -4, so it's gonna be adding 4
Hmm.
over 2 minus -3. So it's
Good.
gonna be -1 over 5.
Good
So it's
job.
gonna be -1/5.
Okay, good. So among these slopes, then which lines are parallel to each other? Yeah, Timothy?
Oh,
Yeah, green and blue. Good job. So the green and blue lines are parallel to each other, but not the red line. And that's why algebra is very important, because geometry is limited by our eyesight. And sometimes it's kind of difficult for our eyesight to tell which ones are actually parallel or not. But the careful calculation can really reveal the truth. So that's that. Now, a second type of questions you are frequently going to encounter is they will ask you, okay, we have a equation, and they want you to write another equation of a line that passes through a certain point and is parallel to this line. So by them telling us it is parallel to this line, what is the slope of the new line that I want?
if the wait, you're saying if the slope of the line is parallel to
As
that
they said,
one,
be
um,
parallel to this line. So what would
so
this?
so if you're trying to find x, don't you put y in as 0?
I'm trying to find like y equals to mx plus b as the general format for a line, right? A linear.
Oh, okay. So you're trying to turn the
So
coordinates into y equals mx plus b.
yes, but I'm interested in finding out m and b particularly. So I'm trying to
Okay,
find m
so I
first.
mean, the slope's the same. If the slope's going to be the same, it's parallel, so
Right.
it's going to be y equals 2x.
Right. So we're going to say m equals to 2 first, right?
Sorry,
And
m
then,
equals 2. So,
yeah. Mhm.
and then if m equals, wait, m, or sorry, y equals 2x minus 4. But that's not the
Not quite that.
y-intercept, so it's
Okay.
going to be,
All right, let me walk you through, because the other people are kind of confused too, I think. So I'm going to do it in two ways. One way, so this is shared, right? This is
oh, it's
shared.
the slope is 2, so you can go,
Hmm.
so it's going up by 2 every time. So it's going to be if x is 5, sorry, x1 is 5, x2 is going to be 7.
That could
And
work. So my method one is to say, okay, I know I have this form, so I'm going to plug it in. I would just say y equals to 2x plus b. And I'm told that I need to go through this particular point over here, but that just means x is equal to 5 and y is equal to -4 for a particular coordinate. So I can plug it in here in this equation to say, oh, -4 is equal to 2 times 5 plus b. Hence, -4 is equal to 10 plus b. Then b is actually -14. And once I have m equals to 2, b equals to -14, I get y equals to 2x minus 14. Now, if you plug in 5, you see that indeed give me the answer that I need. This is my method 1. The method 2 is what we kind of did last time. We have another format of this. Instead of mx plus b, we can say this is y minus y1 equals to m x minus x1, right? So this is the using the point slope formula, while the one on the left-hand side is using the slope intercept form. Okay, and if I use the point slope formula, I plug in the point, I can just get y minus, what's the y coordinate? -4, and m is 2, and then x minus 5. So we'll get y plus 4 is equal to 2x minus 10. Then if I move the 4 to the other side, y is 2x minus 14, so we get the same thing. So you could start solving this. Well, they both start with the same way. They both start by identifying m is 2. And then we can use either the slope intercept form directly, the mx plus b, or you can use the point slope form with the y1, y2, x1, y1. Is that okay? Make sense? All right, cool. Time to do some practice problems. All right, let's give these two a try. Okay, Camille, you let me know once you solve number 1, okay?
Okay, yeah, no, I'm just finding the slope for b right now.
Okay, sounds good.
I got 1. So it's not parallel because the slope for b is greater.
Okay, yeah, let's see here. So for the first one slope, we're gonna do -1 minus 3, and then on the bottom we do -6 minus -5, right? So we're gonna get -4 over -1, so we get a 4. And now on the other hand, the other one, we do -7 minus -2 over 2 minus 3. So we'll get a -5 over 1, which is -5. So this one's actually smaller because it's a negative number, but they're not the same, right? The key thing is they're not the same. So yeah, actually, hold on. Did I do this wrong? This is -5 and 2 minus 3. This is -1. This is +5. You're right. Sorry, I messed up. It should be +5. So yeah, indeed, the second slope is bigger and they're not the same. So they are not parallel lines. They have different slopes. So they are not parallel. Okay, good. All right, let's try number 2 and let me know when you're done.
I got two. It's y equals 1/4 x plus 3, I think.
Yep, that is correct. Good job. So let me work it out. Let's see here. We have a line that passes through or is parallel to that one. So we know the m is 1/4. And if I do y equals to mx plus b, then I can say 2 is equal to 1/4 times -4 plus b. Hence, 2 is equal to -1 plus b. B is 3. So therefore, the whole equation should be y equals to 1/4 x plus 3. And that will be the equation of a line that passes through -4, 2 and is parallel to the other line. Okay, all right, good job. So that's the typical things we were asked to solve a lot of times. So next, perpendicular lines. So perpendicular lines follow this interesting phenomenon that any slope that you can have a 90-degree thing and it will be perpendicular. In particular, vertical lines and horizontal lines are always perpendicular to each other. The vertical lines are the ones that we will say has an undefined slope, while the horizontal lines have a slope equal to 0, right? And then for the vertical lines, we say m is undefined, because we're basically dividing a number by 0. We can say like the slope is infinity almost. So how do we do this? Remember, the product of two numbers, if they're negative reciprocal, they need to multiply to give you -1. That's a quick check that you can do. But normally I don't use this one. I'll just think about, oh, what's a number's negative reciprocal? Let's say here, -2, right? That turns into a negative of that will be +2. A reciprocal of 2 will be 1/2. And hence that's where they get this one from, right? So negative reciprocal means that you need to flip the sign, and also you need to flip the top and bottom. Okay, that's how you get a perpendicular line slope. So let's take a look at some example problems. Let's say for this one over here, we have three equations and I'm trying to figure out, are they perpendicular to each other? So the slope of this one is 4. And the slope of this one, to solve for that, so y, or 4y is equal to -x plus 3. I just subtracted x on both sides. And then I can say y is equal to -1/4 x plus 3/4, right? Dividing both sides by 4. That's what I'm going to get. And therefore, the m for this one is -1/4. Now for the last one, well, same thing, I'm going to solve it. So I'm going to do this. -2x minus 16 is equal to positive ay. So y, if I divide both sides by 8, we'll get -1/4 x minus 2. And then therefore m is also -1/4 in this case. Okay, so with that said, I look at these, okay, which ones are perpendicular to which ones? Well, first I see line B and C are actually parallel. And line A is perpendicular to both line B and line C. Because we can do a double check. There are negative reciprocals. If I do multiply 4 by -1/4, I do get -1, right? Hence, they are indeed negative reciprocals. So line A is perpendicular to both line B and line C, like that. Okay, all right, cool. Now, just like the one we did before, what if now I am asked to write an equation for a perpendicular line through a certain point? So look at this problem versus the problem we did earlier. They look very similar. They only changed one word. Instead of finding a parallel line, they're now asking us to find a perpendicular line. So step one, same thing, I need to figure out the slope. But we're not going to copy the original slope, but rather turn it into its negative reciprocal. What's negative of 1/2? -1/2. What's reciprocal of 1/2? 2. So it turns into a -2. Okay, and therefore we're going to find the slope of a line. Let's say y equals to mx plus b. Well, actually, I'm going to use the other one. Why not? just to show you that both works. I'm going to do y minus y1 equals to mx minus x1 using the coordinates x is -3 and y is x1 or y1 is these. And then so I say y minus 1 is equal to the slope, -2, x minus -3. So simplify that a little bit. Y minus 1 is equal to -2x. That's a plus 3, so -6. And I can say y is equal to -2x minus 5. And I can check, right? If I plug in -3, that'll be 6. 6 minus 5, I do get 1, so this sure works. Okay, so that is the line that will be perpendicular to this line. And just graph it real quick to convince ourselves that this works out. So we get 1/2 x plus 3, 0.5x plus 3. And then the other one, what do we get? -2x minus 5, right? -2x minus 5. And you can see that, yeah, that's a pretty good 90-degree angle, right? So works out. Okay, cool. Now your turn. Similar types, we're determining whether they are perpendicular or not, and then finding a line through a certain point and I want it to be perpendicular to an existing equation. So give that a try.
Step 1.
Daniel, you came late, so you missed important parts of today's class. So next time, try to be on time, okay? I assume you're probably quite lost as what we're doing right now. We are checking if the lines are parallel or perpendicular by checking the slopes. So first step, you want to rewrite these equations so you can figure out what their slopes are, okay?
Perpendicular is when they have a different slope but the same y-intercept, right?
No, a perpendicular line will have a slope that is a negative reciprocal. That's the number of pairs I try
So
to show you.
is
So
that
if,
like if it was 1/2 it'd be -2?
yeah, mhm.
Okay.
It has nothing to do with the intercept, just the slopes matter.
I think I have 3 then.
Sorry, you have what?
I have
Oh, you have three
3,
down.
I
Okay,
think.
sure. What's
Um,
the slope for the first line?
so none of them are parallel. And then A and C are perpendicular. Wait,
Okay.
no they're not. It's 1/2 and my bad. None of them are anything to each other.
Huh. Okay. That's not correct. So let me help
I'm a
you
bit
through.
confused because we're given them all, and line B is already in slope intercept form.
Right. So we don't have to do anything with line B, right? So let's do line A first. So for line A, we have 2x plus 6y equals to -3. So I'm going to move the 2x over. So I can say 6y is negative 2x minus 3, right? I'm going to get rid of the 6 by dividing. So
So
y
that's
is
y
equal
equals negative
to 2x
1.
6 minus 3 over 6, right? So yeah, right, it's going to be negative 1/3 x minus 1/2, right? So the slope is negative 1/3. And then line B, we already know the slope, right? M is equal to 3. Okay, and then for line C, we need to do a little bit of a math. So again, move that over. Negative 6y is equal to negative 18x plus 9 divided by 6. Y is equal to 3x
Minus
minus
2/3 or
3.
3/2.
Yeah, good. So what are the slope here? M is equal to 3. So now with these three slopes, which ones are perpendicular? Which ones are parallel?
Um, are we only paying attention to the slopes?
Yes, only slopes matter.
Oh, then A is perpendicular to B and C.
Yeah, I can draw it on the graph really easily, right? So let's see if we have a slope of 3, something
And
like
then I
this.
think
Yeah, a
B and
slope of
C
negative
are
1/3,
B and C
like
are
that.
parallel.
Yeah, that is correct. But listen first, you see, like these two lines are perpendicular, right?
Mhm.
But I can move this line up and down. They're still perpendicular. But when I move it up and down, what am I changing? I'm not changing the slope, I'm changing the
The
y-intercept,
intercept.
right? So therefore, the y-intercept doesn't matter. As long as the slopes fulfill this negative reciprocal criteria, this intercept doesn't really matter. They will be perpendicular. So
Mm.
yeah. So A is perpendicular to B, A is perpendicular to C, and B is parallel to C. Yep. So that's all. All right, let's try number 4.
I think I was confusing myself. Um, for 4, is it y equals 1/3 x plus 6? You're still on mute.
Yeah, thank you. Yeah, we have the slope that was originally -3, so I want something that's perpendicular to it, then that turns into negative, which is +3. Reciprocal becomes 1/3.
1/3.
Yep,
Yeah.
good. we're gonna have y equals to 1/3 of x plus b. And if I plug in the values, 5 is equal to 1/3 times -3 plus b. Then that will be 5 equals to -1 plus b. Then b is equal to 6. So therefore, we have y equals to 1/3 x plus 6. Good job. That is the perpendicular line. All right, cool. So let's try to do a more or less a work problem or application problem. So let's give it a try. Okay, so for this problem over here, we have a helicopter, search and rescue crew. The shortest path to the shoreline is one that is perpendicular to the shoreline. So if the shore is the one that's done in green, and we're going to try to write an equation that represents this particular path. Okay, notice that in the passage, they did not give us any points, right? However, in the picture, I do get some coordinates. In particular, I know my current location of the helicopter is at 14.4, but I'm trying to get to the shore as quickly as possible to get water, maybe. But what is the equation for the shore or for this line? If I try to get the equation for this line directly, I might want to try to get like a good whole number part. So maybe I could use this one, right? So if I just do it directly, trying to get the slope of this or the equation for this, I can say, oh, maybe that's 12.1, right? 12.1. And then the slope between that will be 4 minus 1 over 14 minus 12, which will be 3 over 2, right? And I can say, oh, that's let's say y minus 1 equals to 3 over 2, x minus 12. Then y minus 1 is equal to, let's just say 1.5x minus, that would be 18. So y is equal to 1.5x minus 17 or something like that, right? So that will be my guess if I just do directly take a point here and then do the line for that. But now let's try to do the perpendicular line method. So for the perpendicular line, I need to first figure out this line slope. So can you guys spot any good points for me to use for this line? No, I don't think 4.2, 4.1, right? 4.1 could work, right? So that one could work, 4.1, right? What's another point I can use on this one? No, 3,
7, comma, -1.
7, -1. Yeah, that's a pretty good point that goes through that. So let's use these points, right? Okay, so same thing. I'm going to try to figure out do the green for the green line. So I'm going to do -1 minus 1 over -7 minus, sorry, that's not -7, +7. +7, +7 minus 4. So I will get -2 over 3, right? So that's the slope. Now I don't really need the equation for the line again, right? Because I don't need to know the intercept. I just need to know the slope. But then from that, I can try to figure out, oh, what is the red line slope that I need? The m of the red line is called the m prime. It needs to negative reciprocal. So the negative reciprocal of that will be 3 over 2. And then that's exactly what we had earlier. So then I can go, oh yeah, I need a line that has a slope of 3 over 2 and I need 14.4. So let's do y minus 4 equals to, let's just 1.5, x minus 14, right? So that will give me y minus 4 is equal to 1.5x minus, that's 21. And then say y equals to 1.5x plus, minus 17, right? Because I've added 4 to it. And that's precisely the same result as if I just got it from directly getting the point. So in case if this red line doesn't have any nice point, but the green line has nice points, we could do this method, right? We could find the slope of the green line and then use the red line's point to work together with it to find out the equation. Okay? All right, cool. So that's that. Let's work out a couple questions and then we'll take a break. So let's see here. For 13 and 14, determine which of the lines, if any, are parallel or perpendicular. and then try to explain. So they color coded it, which is nice, but it's kind of messy. So make sure you keep track of which point is on which line. They did colors, so that's nice. And yeah, let's see which ones are parallel, which ones are perpendicular. Let's give it a try.
13, I don't think that any are I mean the blue and green ones to me look parallel, but what I got doesn't say they're parallel.
Yep, you're correct. None of the lines are parallel and none of them are perpendicular. So let's find
Oh,
the,
I got it right.
yep, good job. So let's do the blue one first, right? So what's the slope of the blue one? Well, the blue one went 2 unit to the right and then 3 unit up, right? So this is the slope of 3/2 for the blue. Right, so 3/2 for the slope for the blue. And then what about the red? Let's see, the red over here, it went 1, 2, 3, 4, 4 unit to the right, and then 2 unit down. So for the red, that's going to be a good old -2/4, which is 1/2, right? And then for the green, we can do a similar trick. It goes 1, 2, 3 to the right, and then 1, 2, 3, 4, 5 up, right? From negatives. Hold on. What am I doing? I want to do the. Oh yeah, that is great. So from -6 all the way to -1, that's a up of 5. And then from -3 to 0, that's a right-hand side of 3. So therefore, the green one will have a slope of 5/3. And if we look at that, yeah, none of them are equal or negative reciprocal of each other. So even though these two values are really close to each other, right? This one is like 1.5 and this one's like 1.667, right? They're pretty close, but they're not the same. So they're not parallel. Yeah. Okay, good. So that's that. And the red one, yeah, that doesn't even look like it's perpendicular to them. So okay, let's do 14.
Or the green one, are we using 0, 0 as x1 or and y1?
Yes, you can do that. 0, 0 is x1,
Okay.
y1. All right, I got an answer from Daniel. Good.
Um, so blue and red are parallel, and then I don't think any of them are perpendicular.
Yep, that is correct. So let's again try to find the slope of each one. So for the red one, we went 3 unit to the right and 1 unit down, right? So red one has a slope of -1/3. The blue one has a slope of, again, 3 unit to the right and 1 unit down, so -1/3 again for the blue. And for the green, we went 0, 0, 2 unit to the right and then 5 unit upward. So the green has a slope 5/2. And 5/2 is not reciprocal to any of these guys, right? However, these two are indeed the same, so they're parallel. So we can say the red is parallel to the blue, but nothing else. Yep, good job. Okay, let's take a short break, come back at 5:18, and then we'll continue from there. Okay, take a short break. Go ahead and resume. Okay, so that's the finding them from the graph. Now we are going to see if we can find equations that is perpendicular to these lines given points. So these two practices. The first one gives you the 0.710 to give you an equation y equals to 1/2 x minus 9. You are to find a line that is perpendicular to the given line and going through the given point. So we tried that before. So let's try these two together. Hey, let's try this over.
For 13, is it y equals negative 2x plus 24?
That is correct. Good job. So because this is 1/2, so we need an m that's negative and flip that, so 2. So well, 10 equals to negative 2 times 7, so this is y equals to mx plus b. So negative 2 times 7 plus 10, sorry, plus b, right? So therefore, 10 equals to negative 14 plus b, and put the 14 on the left, and that's b equals to 24. Thus, y equals to negative 2x plus 24. That's the equation that will go through that point and at the same time be perpendicular. Right, let's go take a look. Check, right? So if we have the original equation, that's half x minus 9, so x over 2 minus 9. Then our new equation is negative 2x plus 24. So you see they are indeed perpendicular to each other, and does it go through the point 710? 7/10. Right there. Yeah. So you see it does go through that, and then we're going to take it into the Good job. 20.
For a reciprocal of a fraction,
Mhm.
is it just inverse to negative?
Yep, exactly. Flip the top and bottom, and then put an A.
So it'd be negative 3/4 in this
Yep.
case? Okay, thank you. Is it y equals negative 3/4 x minus 4? Oh, you're on mute.
My bad, to do yes, that is correct, because if I do plug in -4 into this, we're going to get a +3 minus 4, and that is indeed getting around to 1, right? So this is done correctly. Good job, and that is indeed the line, the equation of the line that will go through this point and also be perpendicular to the given value. Good job. Okay, so we are done with this calculation intensive part. The next part I want to go over is more theoretical, not theoretical, I should say conceptual, because you're not going to be required to do a lot of calculation on this. In fact, if you are to do this, you will be relying on computers. You will be relying on technology to do. So we're talking about scatter plots and lines of fit. So first of all, what is a scatter plot? What does that sound like? It sounds like something scattered. Yeah, that is exactly what it is. We're going to scatter a bunch of points that relates kind of like to data and put them there, and then we try to see how they are like distributed. So a scatter plot is a graph that shows the relationship between two data sets. Okay, and for example, let's see here. Here is a graph of correlations between married couples, right? Age of married couples. We have a bunch of people, and then we have husband's age and then wife's age, right? So essentially, we interview a bunch of couples, and let's see this point over here. What does that represent? That means this particular couple, the husband is maybe around 43, and then the wife is around 47, right? That's what this dot means. And let's see this dot over here. That means the husband is maybe 49, and then the wife is about 44, perhaps. Right. So each of these dots represents a couple, married couple. And then we just plot them, all of them, hundreds of them together, and see if we can discern a pattern. So what do we see here? Well, we see that, yeah, generally as the husband's age increases, the wife's age increases. Makes sense because people generally want to marry someone they're roughly the same age, right? Occasionally you will see like really old and young couples, but that's rare, relatively rare. So for example, we have some outliers. There's one way out here, the wife is like 62 and the husband is like 53. So they're like 10 years apart, right? That's a pretty rare. And then this one over here, the husband is like 70, while the wife is like 50, 58. So that's like 12 years apart. Yeah, so those are relatively rare, but most people follow this one. Yeah. And then here is another scatter plot in relay other things. For example, this is a plot that plots age of American woman at first marriage. So when do they first marry? So in the 1960s, apparently, women on average marry when they're 20 years old. And then the age generally increases. And by 2010, the average first marriage age for women is about 26, right? So we can see that relationship. Yeah, that's that. But what do we do then, right? Once we plot them together? Well, here's another definition. Well, we can kind of interpret the relationship between them. So for this graph over here, we can safely conclude that as years go by, the average age of American women at first marriage increases, right? Something like that. Okay, and however, that's a very vague statement, and we have come up with certain terms and definitions to help us define and describe things a little bit better. So, for example, if I look at these graphs, each of them tell a story. Right? So we call the story or the relationship between the two variables a correlation, how they're correlated. Relation, correlation. A correlation is a relationship between the data sets. You can use a scatter plot to describe the correlation between data. So this one, we call it a positive correlation. What does positive correlation mean? When X goes up, Y also goes up, right? So that means it's a positive correlation. And we have a negative correlation, which is when X goes up, Y goes down. That's a negative correlation. And then the last one, yeah, it really doesn't show any pattern. I cannot fit a line whether it's go up or go down. They don't fit very well. Then we can say that there is no apparent correlation. Okay, there's no very obvious correlation. Okay. So let's do a quick exercise. Can we classify maybe I'll just put these two pictures on the right. Okay, cool. So very quickly, Daniel, based on the three pictures above and the bottom left picture, the person's age uh, and the number of vehicles owned, is there any correlation between them? What kind of correlation exists between these two quantities? For the bottom left picture, what do you think? You unmuted, but I didn't hear anything. What did you say? I still couldn't hear anything. Is your mic working? Weird. I'm not hearing anything. Can I mute myself? 1 second. Let me check my volume.
You're unmuted. It might just be his mic.
Okay, all right. It's probably his mic then. Oh, okay. I see him typing things to me. Yeah, Daniel says it's no pattern. That is correct. There's no clear pattern here. So therefore, we say there's no correlation. Okay, we say this is no correlation between person's age and number of vehicles owned. Okay, all right, cool. Extra R here. Okay, for the one on the right-hand side, Timothy, what do you think? Do you think it's a positive correlation, a negative correlation, or a no pattern? Look at the picture above. Like, which one does this look like? Yeah, so which is that? This is a negative correlation. Yeah, this one's a negative correlation. So we have, there is a negative correlation between average daily temperature and coats sold per day. Right? Makes sense. If the day is really hot, you're not going to sell that many coats. When the day is cold, people are going to buy coats. Right? Makes sense. Okay, cool. So that's that. Again, like I said, this is going to be fairly conceptual and you're not going to do a lot of correlation. The next part, is about line of best fit. And again, you're not going to do this by hand because doing this calculation by hand is possible, but very tedious. So you're not going to be required to do this by hand. So we are talking about line of best fit. What is line of best fit? A line of best fit is a line that try to minimize the distances between that line and all of the points. Okay, but it is really difficult to draw that accurately by hand. So for example, here, this is what if they put all of the dots, they put the scatter dots, right? They put the scatter dots here, and they try to draw a line that generally kind of fits through all of the points, right? And the computers will do that for you very accurately, but you're not going to be able to do that. So let's see here, we have these dots and you have this line. So this line then can help us to find information. For example, we can try to interpret the slope and the y-intercept of the line of fit. What does that mean? So first of all, let's try to see what's the slope. What's the slope of this line? Well, let me pick this point over here. Maybe that's 216. And let me pick maybe this point over here. Let's call that 8, 4, right? So between these 2 points, I can say, oh, the slope of the line is going to be negative 12 over 6. And that's negative 2. And the y-intercept looks like it's a 20. So I'm going to say the line is y equals to negative 2x plus 20. So how do I interpret this then? What's the slope? The slope is negative 2. We can say the slope of negative 2 means that I cannot spell today, means that for every additional week, right, every time I increase the week by 1, the sales decrease by $2 million, right? Because if I look at the scale on the y-axis, that's what it means. Sales, millions of dollars, and it's dropping down by 2. So therefore, that's what it is. Okay, and that's a meaningful thing. Every additional week is decreased sales by $2 million. And then what does the y-intercept mean? Well, basically, at the initial release, right? That's a 0 week. The sale was at $20 million. Okay, so that's that. All right, cool. So this is still useful because it can help us to get information based on that. Now, again, you're not going to be required to do this, but let me show you how you can do this with technology. So let me use an Excel file or Google, let me use Google Sheet, I think, because everybody has access to Google Sheet. Not everybody has access to Excel. Just create a blank sheet. And we're just going to plug in the data, right? So the week is just 1, 2, 3, 4, 5, 6, 7, 8. I tend to do vertical data. I'm going to say week. So 1, 2, 3. But you can do it horizontally as well, but it really doesn't matter. And we have up to 8 weeks, I think. Right? So delete those 2. And then what are the points I have? 19. Let me do it this way. All right, so we have sales, millions. Okay, so we have 19, 15, 13, 11, 10, 8, 7, 5. Okay, all right, and we're gonna do that. Insert chart, and I don't want a column chart. I want a scatter chart style. I want a scatter plot. There we go. That's a scatter plot. Okay, you can see that. And now I'm gonna add a series. They call it trend line. There we go. So that's the trend line, and then I can show the equation. I think there's an option to show equation, right? Label, yeah, use equation. Okay, and you see, there we go. Instead of an estimated one, we say it's about -2, and then positive 20 for that. But the most accurate, or the computer generated this trend, what's it called? Trend line is -1.83 x plus 19.3. So they can be a lot more accurate than what we just like eyeball it. Okay, and that's why I say you're not going to do this by hand because you're not going to be able to get the decimals accurate. So, okay, cool. So that's that. Now, our main task is not to produce these graphs ourselves, but to be able to interpret the slope, interpret the y-intercept, that kind of stuff. So as long as we're able to do that, we should be okay. Hold on, the book kind of stuck. Oh, there we go. It's not loading the page for some reason. All right, so with that, we have essentially completed chapter 4. So we've gone through quite a bit of material already. We're at the end of chapter 4. So this is the kind of like the chapter 4, end of the chapter quiz. So let's give it a try. Okay. It's not a real quiz. So I'm going to just do it together with you guys and let's see how we do. All right, let's see here. They say graph the function, describe the domain and range for the first one. So we are asked to graph these, what do we call it? Piecewise functions. So hopefully you guys still remember how to do that. Now we're going to skip it because I don't think we really spent too much time on that. Let's skip that. And then let's do the second one. Write the equation of the slope-intercept form of the lines of these characters. This we extensively practice with, so we should be able to do these. Let's give these a try. Some of them will be really easy, some of them will be harder. Daniel and Camille, when you have a question, when you have an answer, just type it in the chat to me. Okay, good. First one, easy. Y is equal to 2 over 5x minus 7. Yep, they literally told us the intercept and the slope, so just write it out. Good. Okay, so this one, I think the correct answer is if we get the slope, that's negative 3 minus 6 over 3 minus 0, right? So that's going to be negative 9 over 3, so that's negative 3. So we should have y equals to negative 3x plus 6, because this is the intercept already, right? So that should be the answer for the second one. 5 and 6 are similar to the ones we just did today, so that should be fresh in our mind. All right, let's work out number 5. Parallel to the line, so that means we have m equals to 3, and it passes through this point, so I want y equals to 3x plus b to be fitting through this line. So -8 is equal to 3 times -2 plus b. So -a is equal to -6 plus b, then b better be -2. So therefore my equation would be y equals to 3x minus 2. And if you do plug the number in, you'll see that works. Okay, so that's that. Hey, good. Once you're finished with some of these, you can move on. Yeah, but I'm gonna give people a little bit more time to work it out.
Point slope form is uh like y
The
minus
Yeah,
y.
the y minus y1 equals to mx minus x1. That's
Yeah.
the point slope form. Uh, Okay, all right, let's do number 6 and then number 7. All right, so perpendicular to the line, this is 1/4, so that means my m needs to be -4, right? Negative reciprocal of that, and I need to pass through this point. So -4 times 1 plus b is equal to 1. So therefore, b has to be 5. So we should have y equals to -4x plus 5 for that to work. So that's that. And for this one, since they literally pointed out, we want to do the point slope form, so that's what we're going to give them. So we're going to say, okay, well, y1 is 2, x1 is 6. We're going to say y minus 2 is equal to slope 10 times x minus 6. That's it. They want it in this form, we're going to give it into this form. I know, Camille, you transformed it into the standard slope intercept form, but since they literally say write it in this form, so we're just going to do it in this form.
Oh, in point slope form. So just keep it the way.
Yeah, just keep it this way. Yeah, you will have
Okay, I
questions
get
in
it.
your class to do that. Yeah. Okay, cool. And then the next one. Yep, good job. That is correct. So this one we can say y minus 2, because the slope, if we do that, it will be -1 minus 2 over 6 minus -3. So the slope we get is -3 over 9, so -1/3. So we plug that in here. Using this point, we can say y minus 2 is equal to -1/3 x plus 3, right? That works. Alternatively, you could also use this point. You can say y plus 1 is equal to -1/3 x minus 6. Either way, both of these will work. Good. We will skip this one because we didn't really do sequences, so that's that. Okay, let's see here. This is a challenging one, but let's give this one a try. Let A, B, C, D be constants, meaning that just numbers, not variables. X and Y are variables. Determine which of the lines, if any, are parallel or perpendicular to each other. So let's try this one out.
So line
Mhm.
1 and 3 are no, they're not. They're not parallel.
They're not parallel. Yeah. Okay,
Um,
let's do this together. So
sorry.
y equals
I'm getting
to
a little bit
a
confused.
x plus c, right? So we have a slope of equal to a here, right? That's what's being multiplied to x. And the last one is y equals to negative a x plus d. So the slope is negative a here. So that's the negative a. That's the slope of these two, and let's figure out the one in the middle.
I mean, the one in the middle is y equals negative x over a minus b over a.
Yep,
So is that perpendicular to 3?
yep. Because this one's slope will be negative 1 over a, right? So negative 1 over a will be perpendicular to which one? To 3 or 1?
1.
To 1, yeah. So therefore, line 1 and 2 are perpendicular to each other, not 3. 3 is neither, right?
Yeah, 3.
Make sense? Yeah, okay.
Mhm.
All right, cool. We'll stop here for today then. And next class, we will be moving on to system of equations. So that's another major topic for Algebra 1, but we'll wait for next time. Okay. All right. I'll see you guys next time. Bye.